Hello, everyone. This is going to be a short video, and I want to cover the last part of Lab 1 here, mainly how to do the uncertainty for your best fit line. To do this, you should pretty much follow um, all the instructions above it. That means take the data for time and position and plot it on a graph. And I'm going to give you sort of like, let's say, approximately what it should look like. So you can take a graphing paper here and make your measurements. Take the measurements and plot it here. So I highly recommend you guys use the entire page. So for example, here you do the position. Here you do, let's say, the time, because position versus time means that position goes on the y-axis, time goes on the x-axis. So this is, let's say, time in seconds. This is position in meters. Then let's say you put your data points. Again, I'm just making up some points here. So let's say these are my data points. And what I will do here is draw a best fit line. If you're doing it by hand, because I'm okay with you guys to use, for example, iPad and digital pen, that's fine with me as well. But if you're doing it by hand, make sure that you use a ruler to draw a straight line. So what you will do here is for the best fit line, so you will draw a straight line that goes through your data points, not necessarily connecting your data points, but one that goes through your data points. So this is your best fit line. And what we do here in this particular part of the lab is to learn how to take the best fit line, find the slope of the best fit line, which you choose 2 points, any 2 points on the line, because one of the things you need to understand is that when you're doing the, let's say, the calculating the slope of the line, you have to understand that the data points that are not on the line cannot be used. For example, this data point, it's not on the line. So you cannot use that data point to calculate the slope of the line. What you do here, just any 2 points, on the best fit line, and then you calculate rise over run. And that will give you the slope, let's say slope M. Because what we have here is if you're doing y equals mx, basically graph, then in this case, for example, you have x, you have t, right? So those are kind of plays the role of the quantity on the vertical axis, times plays the role of the quantity on a horizontal axis. That means the slope basically will be, in this case, rise over run, and we'll show that this is linear relationship between position versus time. And then in this particular case, you can also, if you see, right, since rise is nothing but your delta x, run is your delta t. So that means this will give you then the average velocity from the graph. But the velocity is a quantity that we derive from this, let's say, data set. And it also has to come with average plus minus uncertainty, let's say, the way we represent this, right? So we can say this is my final velocity as a quantity, the average plus minus uncertainty. Average is directly the slope of the best fit line. But then to find the uncertainty of this quantity, we have to use the max and minimum lines to determine. I want to quickly go over that. So what we do here is after we go through this data analysis, that means we put all the data points on the graph, draw a best fit line, find the slope of the best fit line. Then you draw 2 more lines. And those 2 lines are going to be maximum lines and minimum lines. So the maximum line should be such that it has all of your data points below it. That means it kind of goes above all your data points. So basically something like that. So this is my maximum line. And then we do a minimum line. The minimum line goes basically such that it's, has all the data points above it. So less steep than the best fit line or the maximum. So something like this. Okay. So maybe something like that, right? So try to do a straight line. As you can see, right, then what you have here, you have best fit line, then you have something that's a little bit steeper, which is the maximum, something that less, which is the minimum. And what we're doing here is we kind of have the best fit line within those 2 points. So this is known as a spread. So this is actually known as a spread, where, kind of equivalent to sort of like this Gaussian distribution, where our best fit line is our average, and we're doing sort of like a spread, where then we say that most of our data points, about 68% of our data points should be within that. But in this case, we do such that all of our data points are within those, maximum minimum lines. So once we draw this maximum minimum lines, then you need to find the slope for each of those lines. So you need to find the slope. So let's say, let me do it like this. Slope for the max. And then you need to find the slope for the minimum line. That means just take 2 points on this maximum line, rise over round, you find its slope. Same thing, right? Take any 2 points on the minimum line, rise over round, find its slope. Then take the difference between those two slopes and divide by 2. Will give you the uncertainty for the velocity or the uncertainty of the best fit line. Again, let me kind of write this down over here, maybe. Make this is a little bit smaller. So think like this. So what we did here is the slope of max minus the slope of minimum line divided by 2. That's then the uncertainty of the slope, right? The best fit line. In this case, since the best fit line represents velocity, the uncertainty will represent the slope of the uncertainty of the slope will represent the uncertainty in velocity. Right. So hopefully this will clarify some things for you when you're doing the last part. And feel free to always contact me if you have any questions.